So, according to table 15.2, riding a bicycle at a racing pace requires an work input of 1270 watts or 1270 joules per seconds. That value is used to calculate the work output to the heat pump. Hence, I have written work is equal to that value. The coefficient of performance equation COP can be found using equation 15.7 to calculate the heat delivered by the heat pump. So according to that equation 15.7, COP is equal to QH over W, where QH is the heat input, W is the work input, that is equal to 1270 watts, and COP is the coefficient of performance. So from this equation, we can find QH to be equal to work input times coefficient of performance. Now it's just time to substitute the values. So COP is this is the value given is the rate of work input. As you can see, this is in joules per second, so that's rate of work input. So to find the amount of work, we need to divide the rate of work input times the time, and that is given to be 1800 seconds. And the coefficient of performance is 2.0. Now calculating this expression, we find QH to be 4.572 times 10 to the power 6 joules, or approximately 4.6 times 10 to the power 6 joules.